Hello, welcome to the stream. We finished the setup just now in the previous stream for the training. So I think it's time for us to do the actual training. I will start with implementing DQN first. But before that, I just want to update a few things. So I think this one is streamed in 1080p. I think previously I didn't set it up correctly, so it was streaming at 730p, and the code was quite hard to read. So I'm now streaming at 1080p. So this should resolve the resolution problem, hopefully. And secondly, I think I've been doing some random stuff to make our channel look better. So its channel ologn is our new YouTube channel. We already have 3 subscribers, so I've been working on this, branding thing, like this our image and the logo. So I think this one looks pretty nice. I just spent like 10 minutes doing them. You can see I did the banner in Google Slides. So this is like a arc shape. It looks like ologn graph, so I'm taking that. It's just some very simple graphics, same as the logo. I think for the logo, I couldn't fit everything in the bottom because of how ologn graph works. So I had to put the O above it. It looks kind of different, but I think it looks fine to me right now. Like this is fine, right? So I think it's fine. And if we click on one of these videos, we should be able to see the new logo. Apparently not. Writing some. Apparently it's still the old logo, but whatever. It's fine. Yeah, so that's the update for our channel. I think we're also live right now, which is pretty cool. All right, so let's go ahead and start doing this DQN implementation. So for those of you who don't really understand what's happening with the DQN, it's basically a machine learning, a reinforcement learning algorithm that progressively gets better. So the key thing that is required for DQN is the state, action, and reward pair. So you need a state, an action you've taken, and then the reward you've gotten. So these 3 are like kind of training data, and you need like quite a huge number of them to be able to train a meaningful result. So I think somewhere between 1 million to 10 million iterations would yield us a good result for a simple game. I'm not sure how much is required for this game. Depends on a lot of factors like how you encode the state, how you encode the action, stuff like that. So for me, personally, I like the idea of just encoding useful things in the state and also just high-level strategies in the action. So for example, this guy asked, how to make state key. I made a comment, so you can see I think I'm gonna follow this one. So I think I'm gonna encode the useful information in the size times x vector. So the x is the number of useful informations, such as the amount of core on a given cell. So the size times x is the board size, right? And then the x is the useful information on that specific cell. So I think the first useful information is the number of cores for sure. Second information is whether that's a our shipyard. Third information is whether that's enemy shipyard. Fourth information is whether that's our fleet. And the fifth information is whether that's someone else's fleet. I think these are 5 things I want to encode first. And then the action output, it would be a scalar of about 0 to 10, depending on how many actions we have. So it's a pretty straightforward setup for DQN, I would say. And then, of course, this 0 to 1 will get translated into, our strategies, which we already written here. So we have all these strategies. So the difference between machine learning and rule-based is that, instead of hard coding, instead of hard coding the priorities of different strategies, we'll use the machine learning model to decide which strategy to take. So we can get rid of all these hard-coded strategies, right? So that's the idea. I think I'm gonna keep this bot for reference. So this is the I would say let's call this a rule bot, right? So this is a rule-based bot, and we're gonna build a new one which is machine learning based, right? Model based. So these are quite different. And then I don't think I want to evaluate this against the rule-based one. I think I'll just evaluate against the old bots that we already written. So I'm gonna delete this later. Let's think of how to structure our code first. So this is basically an agent, right? So what we've written here is essentially an agent. So on each tick is gonna act by processing the information from the board. So this is a act loop. So I think it's fine. Let's take a look at our existing DQN code that I've written for another game. So this one I've specifically written the DQN for 2048 based on the TFJS starter template demo. So can see here the key thing is we need a state tensor. So this is gonna take a state, which is in case is our board, and then to return a tensor. So this is what we need, and then we need a game agent class. Okay, so the game agent class is gonna control what to do, right? For each game. So this one kind of has to be persistent, right? It contains a model as well, so I think we'll need to write that one here, right? Game agent. Right, so what we could do is we can delegate most of this logic to the agent. We could just write the tick as a function of the agent, right? So something like that. So once we have the agent can act and learn, and it's gonna train and stuff like that, right? I think the get move is similar to the tick function. I think there's quite a lot of parallels in these two implementations. I think we could just kind of do it already, right? So let's start by implementing the most important things. So the first thing that is very important is the get state as tensor function. This one is going to take a state and then return a tensor. So we'll definitely need this one. Let's see. So the environment is actually supposed to be static. Okay, we don't need this one anymore. So the environment is supposed to be static in terms of width and height and number of states. Wait, so what is number of states? I think we don't need this anymore. And in our case, because the board is only passed to us in the first run, so we need to decide whether we want to initialize the game each agent on the first run or initialize it outside, right? It doesn't seem to be a good strategy to initialize it outside because we wouldn't know how big the board size is. We know it now that it's 31, but it might change, right? So I guess. So this is a sample file. You can see here the size is 31, which is we can assume it's constant, but we might not be. Anyway, let's start writing. I think this one we can copy here. It's gonna. So this one is gonna change a lot of things here. What's the best way to structure this? I almost feel like we should write a separate file for the agent. I feel like we should write a separate file for the agent. I think that's probably a better idea. Yeah, let's write a separate file for the agent. I don't want to make things all tied up together. So this will be the game agent. Let's actually call it DQN game agent. Now we're just gonna copy this whole thing over. Hopefully it works. Okay, so we need a TensorFlow TF.js for sure. Okay, interesting. I'm not sure whether we're using yarn or npm. Let me check. And I can't tell if we're using yarn or npm. God, there's so many random stuff. Okay, we're using npm. So npm install TensorFlow.js. Not gonna bother with the node and GPU one for now. And then this should turn, yeah, this is fine now. And we need the copy weight and create DQN network. We will just copy it over here instead of, redoing everything again. So we just copy this code here. And then we already declared the license above, so we don't really need to worry about copyright issues here. I think previously I was using a input shape of height, weight, and vector length, which I think we can actually reuse. And then we have two layers of 100 neurons each. And then of course we output the number of actions as the output. So that's all fine. We don't need this anymore. We need the replay memory. So the replay memory is actually, I mean, technically it was written by this Google startup, but I did some modifications. Let's just copy this over. I will just put it in here. I don't know where to put it. Actually, let me delete all those random files first. It's hurting my eyes to see them. So let's remove all of them. These ones. Okay. These. I should really put them in the correct place. Okay, so now that's much cleaner. Actually, let's remove this two first as well. Okay. Replay memory. Okay, right. Replay memory. We'll put it in a util, I guess. Let's create a new folder called tf util. I don't know. Place the replay memory here. And here we're gonna go to tf util. Cannot find. Oh, we put it in the wrong place. Okay, now that should be fine. All right, assert positive integer, get random integer, tf utils. Okay, we have another utils here for some reason. Okay, sure. So we got this get random move. We don't need this. Actually, get random move. Okay, so let me think. Get random move. We do need a get random move in case we cannot find anything. But I think we could just return 0. So instead of this and just return 0, just return 0. Okay. AI config, this don't need this. Agent game interface. This is for the 2048. I feel like we don't need this anymore. Yeah, let's get rid of this. All moves, fixed size array. Okay, we need the fixed size array, but I think I already have this somewhere. Yeah, I already have this. In the util, right? Okay, so we already have this in the util. We don't need other things. Let's remove this, remove this, remove this, remove this. Okay. Environment. Okay, right. So we can't get the environment. So let's remove all these random things. So how do you want to approach this problem of not having env? I think we can take in a board. And then just do board.configuration.size. So that should be fine. Number of states, we don't need this anymore. Okay, so this one will be called get env instead of env. Configuration, this one will leave this as it is. I think the train frame interval is not gonna be used in this case. Max actor length, okay, sure. Fixed size array limit number of action equal to all move dot length. Okay, so we need to define all the moves. We need to define all the moves actually. So let's do that. So let's see how many strategies do we actually have. I think let's not deal with too many of them right now. I think we'll just do like basic ones. Okay, we just do mine medium, build ship, and frontline, and build shipyard. Right? So this 3 I feel like is a good starting point to deal with this kind of things. All right. Export const all moves equals to interface move is we'll assign a action index, right? The index would be a number, and a name. Name should be a move name. So we'll create an unknown move name. Okay. So we have mine, build ship, sure. Build shipyard, yes. Send ship to file. Okay, that's too advanced. Not gonna do that. The mine, build ship, and build shipyard. I think this is fine. We just need this 3, right? All right. So the all moves is an array of moves. So we have index 0, move, build ship, sure. X1, build shipyard, sure. X2, mine, sure. Oh, I forgot. There's a do nothing. Do nothing. Well, actually, I want this to be the first one, this to be the second one, this to be the third one. Duplicate this. Third one, build ship, build shipyard. Okay. This sort will give us the priority as well. So do nothing, mine, build ship, build shipyard. Sure. I think that's enough for the all moves. So now we can actually import the all moves .length. Get state tensor, state equals to a board. So we can't get this anymore. Okay, this is interesting now. Okay, so we need to encode the information. So let's design the state tensor a little bit. So I think state tensor vector. For state tensor vector, let's see, 0, we want to put we need, okay, so 0 we put core, and 1 would put a player fleet ship count. Opponent ship count is player shipyard ship count, and force is opponent shipyard ship count. Okay, this should be correct. This should be correct. And then let's put the core and the player fleet ship count. Okay, so let's put say, let's go one by one. What is cells? Oh, shipyard ID and fleet ID and core. Okay. Oh, okay. That's interesting. That's interesting. So we could just use this actually. Mixed lateral lens, let's make it 5 so that we don't have too many things. All right, all right. Wait, can we actually get the board state though? I don't think we can. Can we? Oh, we should be able to do it, right? I think. Just need to call the board from raw configuration and raw observation. Yeah, it should be possible. Mm. Okay, let's do this. Do we need to move history? I don't think we need it right now. Let's get rid of this. Create initnet. Okay. I can learn board. I think we have a clone board function. That's pretty convenient. Heuristics, stuff like that. Heuristics, reward function. I think we don't need all of this because we're just gonna get the data. Let's figure this out later. I don't think we need all this. Reward is, let's set it to 0 first. Oh wait, we need to make a move. Oh, we don't actually need to make a move here, so to speak. Right, so we don't need to make a move. Check. We don't need to. Okay, we don't need to check loose for sure. Replay memory and okay, let's ignore all this first. I will figure this out later. It's not replay batch, loss values, fixed size array is a string. I think we don't need the actual act and learn actually. I don't think we need the thing. Yeah, because we're just training after the one episode, so we don't actually need to do it. We do need this though, act without learn. We do need this. So let's do this correctly. Actually, we could use the board. I mean, we could technically use the board dot next to calculate the next move. I don't think that's necessary at all. I don't think it's necessary, so we're just gonna return the action. Yeah. Train on batch, sure. Let's get rid of this. We don't need this. we definitely don't need this. We don't need this at all. We will need this if training. Okay, so we don't need all of this. Sorry, this is a lot of old code, so to speak. So yeah, track agent performance, don't need. If not move, get random move. Okay, actually get random move should take in the board. You know what, let's keep it simple first. Agent performance, get agent string, no need. Reward function, no need, because we already have the reward. 0 or move. Okay. Oh, okay, I see. So get random move, we're just gonna give the move. Wait, why can't I find move? Default move. Or move 0, yeah, sure. Yeah, I think that makes sense. Default, I'm spelling it wrong. Default move. So this is just gonna return default. And now it makes sense. Okay, so my code is green now. Well, okay, but I don't think it works at all. So let's see some of the things. So first we need to initialize an agent, and then we need to check that it's getting the correct stuff, right? So let's try to initialize the agent. Okay, so how do we do this? I don't actually want to touch the bot thing. I don't want to interactively train it. I want to like train it using our new in. So there's two ways we can do this. We can either train it here on tick. This is interesting. So this is a different setup from the previous game. So let's hook up the bot with the agent first, I think. Let's hook up the bot and the agent first. All right, so let's see, we can delete all this. delete all this. We're gonna import the agent in our bot, right? Oh wait, why did we delete all the strategies? Okay, we shouldn't have deleted all the strategies, I guess. So let's just keep one of these. We will just do stuff later. Let's import our agent first. Let's import it here. Agent equals to new game agent. Configurations. Right, configurations. Oh, actually, we don't need to initialize the agent. The agent is already initialized here. Yeah, so we just need to import the agent. DQN agent. Oh, we don't even need to actually care about the agent at all. I just realized we don't need to care about the agent. What am I doing? So I already set this up correctly before. So all that we need to do here is actually to get the get move board, right? So this is gonna return is a move. And then we're gonna switch the move, right? Switch move. Case mine small. Oh, I don't think there's a small. Switch move dot name. Move name, right? So okay, let's write this one by one. I think Copilot is not smart enough to figure this out. Oh, we could technically write a map here as well, right? So I guess that's faster. Move map. Okay, so move dot move dot mine equals to this. Okay, there's a do nothing strategy. Move set strategy map. This is my medium large. What is medium large? The hell is my medium large? I think it's just my medium, right? Did I write it somehow wrongly? Why is this changed? What changed here? Okay. Let's see the strategy here. My medium large, right? Okay, this is correct. So that is correct. Let's see if it's smart enough. Oh no, it didn't figure out the correct thing to add. Never mind. We'll do it manually. I do nothing, I guess it's off, which returns an empty thing. Mine build ship. This one will become build ship strategy. Oh, function, yes. Mine medium large. Mine's build shipyards. Build shipyard. Move. Return. Move. Move cannot be used as the index. Okay, we'll move name. Okay, I feel like this is gonna set up for a disaster later. Let's think carefully on how we want to do this. Let's get rid of the move interface and directly use this here. I think that's a better way so that we can just do this instead of converting around. I think this is gonna save us a lot of converting back and forth between numbers and default move. Okay, so now that's fixed. We need to fix this sign. No, okay. Wait. Okay, move name. Okay, that's fine. Here we got a problem. Yes, that we just can remove the name. So this is gonna be an index. Actually, this should return an index. Oh, okay, this is fine as well. I think this is fine. Okay. So I think the setup is correct now. So we have already hooked up the bot with the agent, and now we need to hook up the training process with the agent, right? So we will have a train batch function, but we're not actually gonna use the act and learn because we're gonna get the results in a batch. Why do we need the original state and the new state? Wait a second. Oh, we do need the next. I guess the next state we can also get it from. Yeah, next state we can also get it from there. So we don't need this function at all. right? We don't need that at all. We just need it to we just need the interpreter to pass us the board, actually, so to speak. So we actually need the board information, which can be a little bit tricky. I don't know. Hopefully it works. Hopefully it works out. Hope I can convert this into the board. Should be possible. Should be possible. We'll find a way to convert it. I think we kind of overlooked that previously when we were writing the interpreter. I didn't realize we need the board. Okay, so now we just need this this information. To replay memory. Okay, it knows what I want. Nice. Next state done. And okay. Original state, next state. Done. This is correct. Okay. Okay, so we have this here. Now we just need to hook up everything. We just need to hook up everything. Where are we saving the model? Wait, where's the save model? Oh, wait, is it here? Oh yeah, it's here. Okay, it's fine. It's fine. Okay, so now we can actually rewrite our interpreter into a training function, into a training script. So this is our interpreter. Let's copy it and name it train DQN. All right. Now I need to convert this into the board. Why did I shoot myself in the foot when I was writing the thing? I mean, I could just so the board is getting it from the raw observation. Okay, so we need to make a few adjustments here to allow training. Let's check if that guy has merged our pull request. It hasn't, so we still have time to do something. I don't know if I want to keep adding to this. I might submit another pull request later once we set this up correctly. So I think the mistake that I made was not taking the configuration into the account. Right? So the configuration is also just a raw string. Yeah, the configuration is also just a raw string, so we could just take that as well. Let's see. So process step result result of step result of configuration. configuration, which is an object. Configuration is an object, so oh no, not here. Oh my god, I added it in the wrong place. It should be here. Okay. Configuration is thing. We don't need all of this. Info raw. Okay, so we got board equals to new. Oh, how do we do this? How did this guy do it? Board.raw. Oh, board.from raw. Okay, actually, never mind. Let me convert this to a draft again, I think. I realized halfway through writing training code, it makes more sense to use the board. So I will make let's cross over this to board.from raw. So this takes in the configuration, right? So we need a JSON.stringify configuration. And then we need a player step for raw. Okay, so we need another JSON stringify. And this is gonna take some to do optimize this conversion thing. Okay, so the board is here, right? What do we have from the board? We have fleet ships cells. Okay. I think we don't need these two at all. Okay, we do need the first one. So we need cores for the cells dot map cell cell dot core, and then we get player fleets equals to map dot fleet dot fleet dot toString, right? Oh, we don't have a toString. Oh my god. Why do you not have a toString? Observation, right? Okay, let's use the observation then. Cell.fleet question mark fleet dot const fleet equals to cell.fleet if fleet return fleet dot observation dot join. Else return is okay. Okay, sure. If log we log this, and then we log a cores.join player fleet.join. Okay, should be fine. Should be fine. It should be fine. Okay, so we've hooked up everything. Let's try and run it. I don't think it works at all, but let's see. Oh, why are we editing the interpreter? We should be editing the training. Where's the train? Yeah, I think we edited the wrong file. Unfortunately, we edited the wrong file. Okay, this is awkward. So this is the interpreter, and this is the train. Okay, okay, saved. Let's see, train, npm compile, node run, train. What is it called? Train DQN. Okay. Let's put them into the replay folder. Not here. So let's create a new folder called replay. Gonna put them into the replay folder. Okay. Okay, I don't think it's gonna work the first run, but let's see. It's just gonna print out random stuff, hopefully. Okay. All right. Okay. Okay, I see. Because we're training in node environment, so it looks like we have to use we are forced to use the node version of TFJS. Looks like that is the case. Why do we have a TF here? Wait a second. We don't need this. Okay, so there's only one import. That's gonna be helpful. So we actually need this one instead. Oh wait, did we initialize the agent? I think we forgot to initialize the agent. Yeah, we didn't initialize the agent. Okay. I guess we could initialize it here. Or do we want it to initialize here? So when should we initialize this? Ideally, it should be here, right? Yeah, let's initialize it here actually. Const agent. Okay, wait a second. So DQN agent dot init net word. Let's see, process steps. Oh wait, we need to initialize it before we start. Huh. Okay, interesting. Okay, I think this is only the problem in the first run. Let's think about this for a second. If we are starting from a old agent, we wouldn't have this problem. And the problem only happens if it's a new agent. Okay, I think I know how to solve this problem. The setup is a little bit different from the previous game because it's a different environment. So it does this, and then the agent init is gonna do all this, and it sets the init to true. Like if it's not init, then we can just return, right? So this will prevent initializing twice. That's good. And then we can just safely call the init, right? So I guess so. So we can even call it act and learn. No, we don't actually want it to act and learn. As strange as it sounds, we don't want it to act and learn. But we need to actually update its epsilon. Replay memory. Okay, so I think to avoid confusion, let's remove the I can learn. I mean, that's an alternative way to run this model, but I'm not doing it right now. I think it's slightly harder to set up the training environment. So we're just gonna do the act without learn. And then we are gonna manually update the update frame count, right? Agent T is a number. And then we're gonna do all these things, I guess. Okay, so we're gonna update the agent. Or maybe we're gonna train agent. Frame count. Okay, so we're only gonna train after 300 frames. Agent. Maybe storyboard is too big. I don't know if I should worry about it. Not too sure if I should worry about it. Okay, I feel like we're doing something wrong here, but I think this should still work. Right? Train agent episodes. Then we'll do this thing. Oops. We're gonna do this thing here. So we're gonna train here. Obviously, we don't care about any of these. source value train. Okay. Episodes plus. So we'll manually control the number of episodes that we send. We're gonna send it like this, and then we're gonna train like this. So that's the idea. So we're gonna manually control how we train this agent instead of automatically, let it play and train in the process. I think that's slightly easier to set up. I'm not sure actually, to be honest, but since we're already here, might as well do this way. Oh, where's the init? Not agent.init. Okay. Okay, so that's done. Let's see here. We need to, oh yeah, we need to reconstruct the board. Right, so I think we should be able to do something right now. Let's see what error do we get. Oh no, still a lot of, okay, I forgot to swap the node thing. Let's swap the node thing. But we need to swap it back. Okay, actually we might not need to swap it back. Oh, but oh yeah, that's a real problem, right? Because I don't know. How are we gonna get the TFGS node working? I don't feel right. We should use this. I don't see any. Actually, I didn't see the problem before. I think it's the environment. I think it's the TS environment. If we set the TF backend manually, maybe we can avoid this problem. Let's see. If we set the backend manually, do we avoid this problem? It's still the same problem. So I think we just need to bypass that thing. Let's see. I think it's a TS configuration somewhere here. Leap, DOM. Yes, next. Let's add the DOM here. Okay, seems to be working. Cannot use import statement outside of a more module. Okay. JS include exclude Why is it suddenly a problem? Okay, oh my god. Okay, let's try to run it again. How did I run it previously? Why I didn't got issue before? Now I got issues. Strange. Strange. Expecting a lot more errors actually. Okay. Canary property undefined. Is there a circular dependency somewhere? Agent all moves. So this one import from the bot. And this one import from the TQ agent. So I think there is a circular dependency. The way to deal with this is to extract all the constants. Let's try the automatic extraction tool. If we select all of these and then use refactor into a new file, would that work? Move name. Okay, I think it worked. Let's rename this. Move. Moves. Yes. Okay, let's see if this works. A fixed size array is not a constructor. So I think running TypeScript is a little bit weird now. Can't quite figure out why this doesn't work. Do I need to recompile everything? It's a little bit strange. Can I extract this out into a new file maybe? I don't know. New file, fix size already. Right, so I don't know if that fixes anything. Let's try. Oh wow, it works. We got into the script. Ooh. Let's see whether that works. Okay, it didn't work. Observation cannot read undefined. Okay, something is wrong in here. Something is wrong here. Here. So let's do a console log of false to see what are we exactly getting here. Or at least it's like something is working. So our initialization code, I think, worked. So the configuration is correct. The observation looks to be correct as well. Player paths. Okay, let's read this. Maybe it's not compatible. Player paths equal to player. Players. JSON players. Wait, did I put the order wrong? Raw observation. Oh my god, I put the order wrong. Oh my god, that's the most silly mistake you could ever have done. I mean, I thought you put the configuration first for sure. Oh well. Oh wow. Something is working. Okay, let's see. The core is working. Okay, let's not print too many things. Cannot read to fixed. Reward. Compile run results. Wait, what? Let's not do this yet. I don't want to deal with the compile run result right now. Did we get the replay files? We did get the replay file. So something is wrong there. And I'm not too sure what. Okay. Okay, it's printing some stuff here. That's a good sign. So let's see. Process step. So we got the core. We got the player fleet. There's no fleet. Core, and there's some fleets going around here. That's good. That's good. Okay. Okay, that's pretty good. That's pretty good. That is actually pretty good. That is actually pretty good. That is actually pretty good. I'm not gonna lie, that is exceeding my expectations. So now that we confirm all these are working, we could just move this logic to the train DQN. I mean, we could leave it here as well, but it's not very useful, I guess. I guess we could print 0 and 0 here. Like we did last time. Right, then we can kind of move all this back to our training code. So in the training code, we need this kind of information. So I guess let's do the one state first. Okay, well, actually we don't need this. We need to write ourselves. We need to write ourselves. Okay, so now this is the we're almost close to the end of the game. So we need the core, and we need the player flick sheet count, and some other stuff. Let's see what's the format. I don't forgot the format here. Alright, so for single, so that's the difference, right? For multiple, we need to set the value. The n is the index of the state. For single, it's always 0. So this is what we need to set. So buffer set. So we do know the cells row and column, right? Okay, so we need to get the position. And then here we can just set position dot x, position dot y. So we'll follow this convention. And then the value, so the 0 is, okay, so well, let's set the state tensor map const tensor index map equals to or 0 player shape count 1, player shape count 2, player shape count 2. Okay, so yeah, so Copilot just did that. Take note, programmers. So set one location. Okay, so that the last one is actually the position in the thing, right? So we need to set the tensor index map flash core, which is 0, and we're gonna set it to cell.core, right? So that's the correct play here. And then for the player fleet ship count, we will get the ship const fleet equals to cell.fleet. If fleet, okay, it's trying to help me, but that's a little bit too much. If fleet, okay, so we need another if else. If fleet dot player, can we get current player? I think we can, right? Yeah, it's current player, and buffer set fleet dot ship count, player ship count, else not current player, then we set this one to this. I think we better set the other one as well, so that we don't get into weird situations. So this is gonna be 0, it's not gonna activate. And then the opposite case, we're gonna set our own ship to 0. Alright, so this is a fleet situation, right? If fleet, and then let's do the shipyard. Okay, that's pretty smart. I think that looks correct. If it's current player, then player shipyard. Okay, it's actually the opposite order. I'm not sure why it's the exact opposite order that is setting it to. A little bit dangerous to make that kind of mistakes. If it's current player, then we set ship count. If not, then we set the opponent ship count. I think it just got the order completely opposite. Okay, so that's the ship count. I think that's it, actually. That is actually it. Right, let's debug the buffer a little bit so that we're not doing something stupid. Buffer dot to tensor dot print, I guess. So print is gonna print I'm not too sure. I think we can just do this. I think we just need to do this. Yeah. Okay. So once we have that, we will do the other thing, which is here, right? So this one is gonna be similar. This one is gonna be similar, but instead of 0, we're gonna put n here. So n. So these are the position of the tensor or the buffer, the dimension of the buffer, the index of the buffer. So this is index 0, index 1, index 3, index 4, and this is a value. I think that is to tensor to string. Okay, we could have done that instead, actually. So we'll do that. Okay, I think this is the setup already. I think that should complete our stuff. Don't know. Okay, we still need to actually do the training process. We haven't actually done the training. So let's do that. I think we'll do it here. So process steps. Right, so this is where we're gonna do the training. Do we have access to DQN agent? Should already have. Yeah, we already have DQN agent. If DQN agent.init, not init, then we will do the DQN agent initnet. Right. Board. And then we're gonna do DQN agent.add replay memory. Add replay memory boards, action reward. Okay, so the action, how do we get the action? How did we get the action before? So I think I have some code here. Oh, it's just here, I guess. Let's see. We need to take care of the off by one error in the last case. So I think we don't record the first one. Let's see. Okay, so status. Status is either active or done. So you can put it here. Okay, so the first, we need to take care of this edge case very carefully, right? So I think the first turn there's no action. And then every turn after will have action. Yeah, so the first turn the action is empty. Oh, we have to convert the action back to that thing. Oh, wow, that is actually some work we have to do. We have to actually convert back the action. Oh yeah, and then it's multiple shipyards, right? So it's kind of hard to model as well. Maybe we need a separate agent for each shipyard. Oh my god, that's gonna make things very, very complicated. I think, yeah. I think that's gonna make things very, very complicated. Yeah. Don't know about that. Status active. Okay. So So this action is string, right? Just take the first action, I guess. Mm. I need to think a way to extract the action from the thing. Or in. Okay. Okay. Actually, we should swap the naming here. Okay. If action equal. Wait, is now equal to now? Okay, it is true. Okay. Um, true to now. Okay. Let done equal to false. If action equal to now, done equal to true. Oh wait, that's not correct. The last turn actually has action. Oh, last turn also doesn't have action. Wait. Wait, it should have action actually. The last turn should have action as well. Oh, it doesn't have action. Hmm. The last turn is the same, right? I think the last turn is the same as the other turns. If done, then we break. Right. So agent died. Stop training. Original state, next state, next state, next state. Okay. Treat the step as it doesn't have the step count. Oh, it does have the step count, but not the last one. Huh. Okay, so we need to handle all these edge cases quite carefully. And I is not equal to 0. And done is if I is not equal to 0. To add, I guess the first one doesn't really matter. We need to add the next one. So how do we handle the last one previously? Let me see. Next state, max -1 reward multiplied by done mask. Done mask is 1. If it's not done, then if it's done, then it's 1. If it's not done, 0. Okay. Kind of forgot how this works. To be honest, it's quite a long time ago since I wrote this. But I'm pretty sure done means whether the game has ended. Yeah, so I'll just believe that I've written it correctly previously. Let's not train with the last one. Let's not train the last one. I think the last one is equal to steps.length -1 -1 -2. Done equal to true. Board current board. Current board. Next board, right? Yes. Next observation goes to steps I+1 maintain agent. Okay, that looks correct. So we're just passing the next observation here. Then we're passing the next sport here. Okay, so the action we need to convert back. So that's a little bit tricky actually to convert it back. Can we find a case where the status is done? Go to active. Oh no, I don't have. Oh, wait, I have a replay that might have the done thing. Let's see. Let's format this. It's JSON. Oh, the first one is errored. Okay. That's fine. Let's try to find where it's done. Oh, they were continuing to play. Where is the reward? Wait, I thought there's a reward somewhere here. Yeah, there should be a rewards here. At the very top. Oh, it's here. Okay, so this one should have the case where it's ended early. So I just want to see what is how it looks like. Can we use the status to detect whether it ended early? Okay, it's a little bit too much information here. That's a little bit too much information here. Can I collapse? Why is this one like so long? The previous one wasn't that bad. Okay, so that one is already done. Okay, so if it's done, then it's just that, right? So we can take that, I guess. So we need to convert the action back to need to convert the actual action back to what it was before. So we can kind of see here. Let's use this as a reference. Okay, let's put this on the right. Okay. Sport get move name from action function action string return a move name if action dot includes C return build shipyard else if includes spawn term build ship includes C and action includes launch, right? Else if action includes launch, then it's mine, right? Else return do nothing. I think that should capture it. Let's try to find some other examples. So long. This is okay. It should be okay. It should be okay. It should be okay, I think. Action. Okay, so this is the string. Get move name from action. Oh no, now we need the reverse. Oh, we need the reverse. We need to map it to an index. Move index. Move name. Okay, that works. I was hoping GitHub Copilot would help me there, and it did. Let's get move name. Okay. Go to default move name. Default move. Oh, sorry. I think I need to export const default move index equal to 0. And then here we'll use the default index. Okay. So the current board, and then we got the action here. We got the reward, the next board, and done, right? Okay, the done order is, why is the order different? That's so weird. Action, reward, next state, done. We should have done before next state. I'm not sure why the order got reversed there. We should follow the same order. Okay, now we add to the memory. Let's log this thing. think we have the board doc step to check if it is correct. Action reward done. Export. Okay. And then we'll do the training here. Add replay memory. We'll do the training here. Train agent after an episode. So we'll do the DQN agent of train agent here, and the episode will be that's the episode number. I think it should be steps.length. Okay. Okay, there's the edge case here. There's an edge case here that we might not have enough. We might not have enough replay memory. Right? So replay memory. Yeah, we might not have enough replay memory. We can do the frame count session thing. Yes. So if this dot frame count session is greater or equal to this dot batch size, then we can train. I think that's safe. That's pretty safe. What else is missing here? Let's see. So we do the train here. Okay, let's just run it. I think it will have a lot of errors, but let's just run it. I don't know what else is wrong. Okay, moves has no exponent number. Okay, let's see. Moves has no exponent. Okay, this one is easy to fix. Okay. Okay, it started training. I mean, it didn't start training, it started in the interpreter. Okay. What the hell? Okay, it's printing out a lot of stuff. So, like, it looks... I don't know what to say, but it's doing something, right? It's doing something. I feel like we almost need to evaluate the loss function. So let's do that, maybe. Oh yeah, we need to clip the reward function as well. I'm pretty sure we need to clip it. Oh, let's log the agent's loss function. But before that, we need to remove all the console log from everywhere. Why there's so many here? Let's remove this and remove this. put it here. Okay, so that we should get rid of these things. Let's get some training stats going here. Let's see. And we might have to rewrite some of these things. Can we get the score of each game? Let's see. Process steps. Okay, I think we can move this out to here. Collect agent stats here. Actually, we can do the compile result, right? We can do the compile result here. I don't know why the compile result didn't work last time. It should actually work. Let's run it again to see if the compile result works. I feel like it should have worked, but I think it was erroring out just now, not sure why. Okay, seems to be working. The action is an object, and I cannot read null of undefined. I guess null means it errored, right? That makes sense. That makes sense. So let's see. Current is current board.stat. Okay, I guess we don't need all this. Action equals to action. Reward done. Okay, we could put the done here. We don't need this. I guess. Yes, I think this is sufficient. Let's handle the null case, even though it's not technically supposed to happen. The learning rate might be a little bit low. Okay. Yeah, so it was erroring out. So something is not right. Something is not right. Okay. Let's see what is wrong. I think at least it's running something, right? Like, I mean, our neural network is actually doing something. The input size is very large. We might need the convolution layer for sure. We'll add that later, but I'm just quite curious whether it works. This thing actually works. Let's see if this guy replied to us. Yeah, okay, good. So I guess we can take a look at the bot class to figure out why it didn't work. So this is act without learn. And we should also print the agent performance. So let's do that. I will do two things at one time. So we'll do the agent performance and also figure out why it was erroring out. So we can do the performance here. I think I have the necessary code to do it. Just this thing. Does not exist. Okay. It looks like I forgot to add this average function into the fixed size array. Okay, now it should work. I'm gonna copy the performance string. Score average. I guess we don't need the score average because we already have it. Performance string equals to this string. And then okay. Oh, I guess we can reuse this. Right, we can reuse this. Okay, let's do this again. Okay, we need to move the learning rate much higher first. Q is none. Oh, okay. Oh, it didn't even go to the get thing. Okay, that's something wrong. Okay, that's definitely something wrong here. Okay, a few things. Let's make the alpha much higher. This is first thing we're gonna change. And then we need to figure out why it didn't work. So let's see how this was running. It's spawning the, oh, it's spawning the Kaggle environment. Oh, that is why it's not working, because the agent was not in, the agent was initialized there. Ah, I see, I see, I see. That's a problem, right? Because of this Python is spawning a new process to take care of those things. That is a problem. That is a problem. It's not accessing the same copy of agent as we have here. Everyone is just doing its own thing. That's a problem of depending on the Python interface, I guess. One way to solve this problem is we save the model and then load it on the next iteration. That means we have to drop the max concurrency to 1. I don't want to deal with concurrency problems. And then we save the model here. So we save the model after each training. And they actually have to save it first as well. So we actually have to initialize it here first. We have to initialize it here, like on top, right? So in the future, we could load existing agents. I mean, that's for sure something we want to do. Oh no, this is need the board as well, so we can't just do it. Oh, that's the problem, chicken egg problem, right? We don't have a board. We actually don't have a board. So we can't start without a board. But once we have a board, we need a agent already. But it's still not supposed to produce like null, right? I feel like that's still something else that is wrong. It didn't even went into this code at all. I guess that's a big. Oh wait, didn't. Let's see if it actually does anything here. think the model loading problem is a separate problem, but we need to figure out why it's erroring out in the first place. We can deal with this problem later. String. Okay. Forgot to save. Loss is 2000. Great loss. Yeah, it just didn't go into that file at all, which is very strange. It spawned the Kaggle env and it's using main.py. Main.py is using this bot, and this bot is using DQN agent. DQN agent is supposed to console log. Oh, it's console logging. Oh, that's why. Oh my god. I forgot the Kaggle environment depends on the console log to get the stuff. So I cannot just console log there. I literally cannot console log there. So I have to remove all the console log. I can do a process env process standard error, right? So I could write something like this. Oh my god, such a silly mistake again. Get you have to move. Okay. So I think console log here is fine. Not too sure though. Not too sure if this is fine. Oh, we could also just check the out log, right? Yeah, it's definitely something. But why is it printing out here config? The dependency is a little bit weird. So I guess I have an agent here, and the other one is also console logging, so I have to remove all the console log for sure. That's a little bit inconvenient. And I also have to remove the board, the what do you call that? The model thingy that prints the model, so I can't do the model summary anymore because that's gonna print to console log. Yeah, it's weird. Okay, now it should at least produce some kind of action, not error, right? So that's what I'm hoping for. And then we can do the loading model, saving model stuff. Okay, the Q value is none, which is concerning. The loss is a value. Q is none, and reward is negative. Okay, at least it's doing something. Which, oh no, what happened? Expected. What is this? Observation is used in training, right? Oh, there's no more next observation, right? At the end of the turn, I think. Yeah, there's no more observation. So, oh, there is an observation still. Ah. Well, I can console log here, no problem. I feel like this thing is throwing an error. Let's make sure that this code runs without error first. Then we can move on to some other stuff. So there's no more observations. Where's the status? I guess it's still training. So maybe the training is asynchronously done for some reason. No, it's synchronous. It's synchronous. I'm not too sure what is happening here. Something's wrong. It prints done, but it's still doing something. So far, these two are okay. Core IO. Core IO is hanging. Couldn't parse the raw observation. Okay, okay. Something is causing it to not end, right? Maybe it's the training that is causing it to not end. Let's just comment out the training code and see if that fixes the problem. So this should get rid of the training code. Let's see if they fix this weird JSON error. We could also just log it there, I guess. Oh, it's still not exiting. But the game has already finished, right? I think the game has already finished. Yeah. Game is already finished. Looks like you're running. Oh no. It's outputting it here. Oh my god. That's bad. Nothing. Okay. Sure. And then it got eliminated somewhere here. Okay, so now here the status is done. That's not the that is not the player. Okay, I guess I can't find it anymore, but it's fine. But I think everything else is working. Just this thing is weird, right? I guess we don't really care about it. Yeah, I guess we don't really care about it. Oh wait, it's outputting into standard error. Okay, anyway, let's forget about this error first, then let's try to train something and see if it actually works, right? So what it's gonna do is it's gonna write a model. It's gonna write the model to a file. It's gonna write a model to a file. Let's see. Oh yeah, it's this thing, right? So oh, we didn't await agent init. Okay, maybe that is why it did not work. It's an asynchronous thing. Hmm. Anyway, let's generate a model first. Because it's a chicken and egg problem. So we need to have a model first before we can do anything, right? So let's just copy all this. What is the run? Okay, it's fine. I'll just make it one. Solver model. Let's create a folder. And then it's gonna read file sync. Oh wait. DQN agent model. Load model does not exist. Okay. Oh, okay. I need to wrap it. I need to wrap it. Okay. So that's the wrong move. What actually is happening is like this. Load model is not defined. Let's fix that. Wait, where is the load model? Okay, it's here. Okay. Guess I forgot to declare it. If I inherited it, I would have gotten this for free, but I think it's fine. I think it's fine. Okay. What about save model? Where's the save model? There's no save model. Okay, that was surprising. Okay, let's save it as well. Training code, run agent, train. And then we're gonna save here. Oh, wait. How to sync. Okay. I think that's fine. So we have the model. It will save the model, but the the actual agent hasn't loaded yet, so we're just taking care of the this side first. Failed to load model, right? Correct. So now it's supposed to generate a new model. It didn't. Okay, I guess it will save it later, so that's fine. Oh no, cannot find handler for file. Okay, I guess we have to use the TFJS node to train here. Gonna become problematic later when we want to run it on the server. At least it's doing something. At least it's doing something. Okay. 2 megabyte of weight looks fine. So now let's load the agent. I think the way it loads the agent is similar to here. For now, let's focus on running it in Node.js first. This is actually synchronous. Okay. It's not in it. It's in it. This is completely synchronous, but we need to load it here. First, we need to make this async. Okay, we need to convert async function to sync function somehow. I think that's a little bit tricky. JSON pass file model file pass. Okay. Here. Gonna export this. Oops. It's like this. No. This. Okay. Add missing imports. Okay, so now this is asynchronous. All this has to be async. Tick returns a board. Okay, I think we need to Google what's the best way to turn a async function to sync. A lot of people are Googling this, but let's see if there's a simple way to do it. This guy is just spilling out nonsense here. Okay, let's figure out a way to do this, I guess. Maybe we need to modify the IO as well. Let's see. Actually, we could just modify this to async. Oh. Wait, what? Oh, okay. We could just write this way. From is gonna return. Just do await. Okay, so that will solve the problem, I think. And then gonna do await. Then we have to turn this into async. And then it's gonna return a promise. And then I have to turn this into await. And of course I have to turn this into asynchronous and promise port, and then everything will be okay. Okay, I think that was easier than I thought because IO is async anyway, right? So there should be a way to do this. Okay. Argument type. It's not. Wait. Run. I don't know. Is this okay for you? Oh, cannot. Wait, why? Tick is return a promise. Port return promise. Port return promise. Argument type of port or is not assignable. I think starter filter rule. Okay. Because we changed the IO, so we have to change everything. But I think that's all that we need to change. Starter as well. Okay, let's see if this works. Loaded. Okay. Reward now. What do you mean by reward now? Why is it reward now? Done is false, reward is now. Something is still completely wrong, I guess. Actually, I have no idea what is wrong. Let's take a look. Please follow the format in the example below. What the hell is happening here? Please follow. I mean, that's what I wrote in the interpreter. Oh, console log. Why is outputting the interpreter's console? Okay, this is getting very, very confusing right now. Let's close everything and reconsider what is happening here. So we have this string script, That spawns the Kaggle environment. The Kaggle environment is gonna call the thing. Is there an import of train DQN that could cause the... Oh, it does. Oh, there's a circular dependency. Of course, that's why. There's a circular dependency here. Oh, I'm glad that I have experience with these kind of things, because otherwise it's gonna take forever to understand why it's wrong. This is a very normal, very common error, I would say, with JavaScript code. So we just have to okay, so we can't get rid of those things. Okay, get model first, and then we're just gonna do get model uh, maybe I should just define it here. I think that's easier. Yeah, sorry, I think I should have defined it here. I think it doesn't make sense to let everyone know what's the current run number. Okay, now this. Okay, now it should be no circular dependency, I hope. Still reward now. Okay. Load model, okay. Have to get rid of the console logs. Oh my god, it's driving me crazy. Load model. It's so weird that we can't use console log. Okay. Okay, at least it's not erroring out. Q value is none. Okay, at least it's not. Oh, so I think we need to initialize it better. So catch failed to initialize, and then we should actually initialize it. I think I always want to initialize it here, so let's do the initialize here. Oh, okay. Oh yeah, now it's, if I'm here, then it's too late. Okay, so I have to initialize it in the bot. Uh, or maybe here. If not initialized, try catch and then initialize and save, right? We need to save as well. And then where does it load? Okay, this is getting very complicated. We think of a clever way to coordinate this too. I want to make sure that when you reach here, the model is always there, right? So I think I should actually try to save it here. Right? So in this way, I can always make sure that it has some kind of model by here, and it also has a file outside so that I can access it here to train. But this would screw things up, right? This would screw things up because it's trying to load before it runs. So instead of doing that, we should do it here. A little bit confusing now. Let's have a variable that model loaded equals to false. If not model loaded, then we try to load the model. And then model loaded true, so that we only load model once. Hopefully this is gonna work out. Not too sure. Not too sure. Let's delete this too. And rerun the whole thing again. Hopefully this time it will work. Okay, it's outputting the files. That's good. Hopefully it's also updating those files. I mean, I wouldn't be able to tell with the time. Q is still none. Q is still none. Let's investigate why the Q is none. because that does seem to be wrong. Maybe it's a dimensionality that I set incorrectly when I convert tensors. Could be the reason. I think I assumed the tensor's dimensionality for some reason. Forgot to that. So the queue is actually empty. I guess it's an empty array. Okay. Queue is just an empty array. Okay, maybe I didn't set the queue at all. Queue values. Oh yeah, definitely didn't set the queue value. Okay. I see. Uh-huh. Okay, so even though we didn't use we didn't train in each action, we should still collect the queue values so that we know whether it's working. So definitely we should do it here. So we already have tf tidy here, so let's do something here. We don't need this anymore. I think this would be fine. We already have state tensor. And online I will predict state tensor argmax. Wait a second. Predict. Okay, so the predict is argmax predict. Okay, so this would supersede this thing. The iframe session count is greater than this, and then we will append this predict results. Why do we need predict result? Okay, because we return it, I guess we don't need this right here. Okay, so now we should be getting the queue value because I forgot to edit. Okay, fine, it's fine. Everything is fine. So now we should get some queue value. I think it's on the range of thousands or hundreds because our loss is like 20k. Q is still none. I guess the first time it's okay to be none, but the second time it shouldn't be. Let's hope that it's not none. Oh, it's still none. No, why? Okay, that means I'm still not doing something correctly. If frame session count, did I actually increment this? Episodes 200, 300. Start training size equals to 125. So it should have something. Let's just remove this. It should actually do something here. They didn't even do anything. still none. Ah, okay. It's still none. Oh. I see why it's none. I see why it's none, because it's in a different process. So I actually couldn't get the performance at all. We couldn't get the performance because it's running in a separate thread. It's not this thread. Okay, so this section is completely useless. It's completely useless. Okay. Complete. Okay. Now, why does it have loss though? I'm not too sure why does it have lost. Okay, let's move this to the bot. I think here we get the loss, right? I think. Oh, here. Actually, here we get the loss. Yeah, here we get the loss. That's without. Yeah, I think using the sub process is not a very good idea. Now I cannot collect the agent statistics very well. Wait a second. Actually, I can't get the stats here. Can't get the stats here. Because I'm training it here. Yeah, I can actually get it here. It's just that I have to do this. I have to do this Q value thingy in the other place. Right. So that's the problem I have to do. Where is it? Values. Yeah, I just have to do this actually. In the train logic. I just have to do this. calculate current queue value. Okay, probably not a good idea to do it here. Mm, let's put it here, I guess. Get state as tensor is here. I think we can export this. Do we already have a dependency? Yes. Okay, this is just to get the statistics. It's gonna slow down the process, but at least we get some statistics here. So that's good. Okay, so now we don't need that logic anymore. Okay, not here. We don't need that logic here. Oh no. Okay. It's fine. It's fine. We'll leave it like that. We'll leave it like that. Yeah, we don't need these two lines here. That's all we're gonna change. Okay, now let's run the training again. This time it should have some Q value. It's gonna be a little bit slower because we have to compute it again. But that's just how I set the environment up. It's pretty bad. Okay, what the hell is this? Oh, that's the... Okay, so the Q value is increasing. Okay, that's pretty good. That's pretty good. The Q value is increasing. Okay, that's all I wanted to know. That is all I wanted to know. Okay. Although it's working. Nice. Yay, it's working. Our DQN setup is working correctly. Okay, let's run this more. Let's run this a bit more. Package.json. We're gonna run like 20 episodes. And we're gonna increment our run number 2. Let's see. We should have some interesting results. Very interesting results coming out. Ooh, this is gonna be interesting. I didn't expect. Okay, it took us 3.5 hours to get this here. I think it's within our expectation, within my expectations. The loss is very high. The Q is 28. Okay, okay, it's okay. And the loss is dropping. The Q is staying, not increasing. That's a little bit worrying. Okay, Q is increasing and loss is dropping. Loss is still very, very high. Should definitely apply some log function to the loss. Okay, the loss is still dropping. The Q is increasing slowly. Our reward is 500. Action 2, reward 500. Okay, it's taking different actions already. That's pretty cool, and our loss is still dropping. Loss is still dropping, Q is increasing. Okay, our reward is still stuck at 500, which means it didn't actually get anything yet. Okay, if it's sending out ships, then why it's still 500? I'm quite curious why it's like not increasing at all. It should have more rewards than 500. What? Why is it still 500? I think our state probably has some problems. That's why it's stuck at 500. Yeah, that's probably why it's stuck at 500. Let's see, our model should be updating. Yeah. Oh no, our model is not updating. Oh no, our model is not updating. Wait a second, our model is not updating. Could be the problem. Oh, that's actually one. Okay, we should look at two. Never mind. Okay, it's updating. It's updating. Okay, so the queue keeps increasing, it's just fine, but the reward is still 500. We are not getting any core at all. Why is that the case? Something wrong, right? That's definitely something wrong. I think we should also print out the other stats that I had previously. So let's add the other stats. I think the alpha and gamma and stuff like that. I will get this thing, right? This thing. And we'll put it here. And then we'll put this here. All right, so the loss is still decreasing, and we keep taking action 0. It's probably not exploring anymore. That's why it's. You can see all the actions are 0. Oh yeah, I guess we should give some negative rewards towards the end. Yeah, we should definitely give some negative rewards towards the end. Let's see, let's log. I think our end turn reward thing is not working. If I equals to or I equals to step length -2. Let's make it 50. And then we're gonna do the run 3. Let's see. Let's see. Yeah, at least we got our DQN set up correctly. So the loss is decreasing, Q is increasing. That means our setup is correct, right? At least to a certain extent. Maybe our state is encoded completely wrong, which is fine, I guess. So you can see this is our alpha. This is the discount factor, gamma. This is epsilon, and this is a batch size. Oh wait, the last turn, it didn't print out the last turn. Okay, so maybe there's a problem with how we're picking up the last turn. Step dot length. Okay, let's see what went wrong here. If done, break. Okay, I see. I see. Okay. Okay. Put this below. Okay. And also let's put this above. So that we know what we're adding into the thing, right? Current next. Just might as well put it here. Step. All right, this should be the run. It's still not where is the frame count? I don't have the frame count here. Let's find the frame count. Frame count. Here. Let's do the frame count here. So it's still not printing the second last step. That's very strange. Let's take a closer look at why it didn't print the last step. Process step. For I equal to smaller than length minus 1. If no action, then already break. Okay. Okay, this is correct. If done, then break. Goes to done. Okay, I guess I should also print done, right? Oh yeah, that makes sense. That makes sense. I shouldn't even care about this. I think that makes more sense. Let's see. So we're already on to our fourth run. The first three is a little bit failed, but let's see. I think this should work. Okay, we got 145 negative reward, which is good. Okay, actually we died on 256, which got us negative reward, which is very good. That would make it better. So our loss is increasing, but it's fine because it's only starting, so it's normal for the loss to increase. Now it's dropping. So this loss doesn't really make sense because I didn't clip it yet. But I'm just seeing like whether it works. Apparently this works. So we are getting the negative rewards at the end. So that is gonna help us tune against the correct action. So far it's only taking action 0, which is a little bit weird. It's not exploring. Wait. Oh, I know, I know why. Because the random action, I coded the random action to be. Holy shit, I forgot. Okay, this is very bad. I coded the random move to be default move. That's completely wrong. Why did I even do that? Oh my god, why did I do this? Okay, let's steal the random function from somewhere else. Where is the random action? Get random integer. Okay. Let's do this. Oh, I think that looks fine to me. Let's get this random integer thing. Now we'll steal the get random return this thing. Okay, that was a very stupid mistake. That's very stupid mistake. So const action index to get random integer number of actions. Number of action is correct. Return action index. Okay. So now it should actually try to explore different things. This is the run, I think. Okay, very exciting. I was wondering why it didn't take any action except for 0. Okay, this might lead to some errors though, so oh, it's still taking 0. Okay, it's already the reward is already null, so that's something weird. What? Something is completely wrong here. Cannot read property of undefined. Length. At shipyard, plan shipyard. 151. Okay, let's take a look at what's wrong. 151 function. This is undefined. Okay. Get this. Move. Oh wait. Okay, so it didn't find the. Okay. Let's see what that's the error. Okay, it's printing out the TFJS stuff. This is supposed to return. Turn an action. Action should be a number for sure. Get random action. Wait. Wait, we already have a get random action. Wait, do I have two get random actions? Wait, what did I change just now? Okay, I'm a little bit confused. Move? Wait. I thought I changed some random move thing. What? very confused right now. Get random integer. You choose. And we got util here. Util random. Okay, we can remove this. And it's just gonna go to here. Wait, what did I change it here accidentally? No, I don't think so. Okay. What happened? I remember I changed something that returns the all move. Oh, this one. Get move random. Oh, okay. I didn't even export this. How was it working at all? Okay, I guess I should remove that. And then this is gonna return me a number, and this is gonna return me a number. This is definitely gonna return me a number. And then I just have the action here. I don't need this anymore. Yeah, it's okay. It won't get stuck. Okay, now this should be correct. Let's try to run this again. Oh. Okay. Some we encounter some problems and we solve them one by one, which is good. Let's see the okay, so it's taking different actions, which is good. Oh, the reward is actually going up already. Wow, that is crazy. That's crazy, and our loss is very high. Okay, the loss is crazy high. Okay, that's our loss is in the range of 19 million. Oh my god. I've never seen anything like that. But I think it's dropping also very fast. Wow, it's actually doing something. It's actually doing something. Yeah, the loss keeps dropping and the queue is increasing slowly. Okay, okay. Oh, now it's just taking 0 actions. That's not good. That's not good. I guess this simple agent means that it can afford to take 0 actions, right? The loss started to increase. I think it's normal. It's normal that the loss start increasing in the beginning, I think. It's not exploring as much as I would like it to be. It's staying. It's not actually taking a lot of actions. I think it makes sense because taking no action actually gave you the same reward as the previous round. So you need to disincentivize it by losing the game. Yeah, so there's a little bit more tuning to be done here. Otherwise, it's just gonna not take action, right? Like this case, it's not taking action and it's somehow winning. This is funny. This is very funny. Because the bots are too easy. I'm playing with the simple bot, and the simple bot is like very easy to beat. I guess It managed to be the simple bot, which is something, which is something, which is something. Okay, the loss is still not making any sense. The loss is not making sense at all. How do I clip the loss in this case? I have to design my own reward function, I feel like. I could just take the log of the reward. Right? That would make sense, I think. Let's watch a few more of this. It's quite fun to watch this. Oh, it's actually ending the game by turn 364. And it's not losing, right? The reward is positive. That means it didn't actually lose. At least that's what I think is happening. Yeah, I think it didn't lose actually. Let me do a quick check on one of these episodes to see if we're losing or winning. Yeah, we're not losing, right? We're not losing, yeah. We're not losing. And this one. 16 is the one that it ends early. Let's see. Oh, we actually lost. Wait, it didn't capture the loss. It didn't capture the loss. Okay, that's some problem. That's problematic. I think it didn't capture the loss. If it lost early. Okay, okay. Have to dig deeper. I think episode 16 ended in 351. So let's take a look at this thing. I think we're looking for step 351. Reward -50 and status equals to done. So okay. Okay, so at this step, we have status done and action empty and reward -50, but we didn't. Oh, we did capture this. Sorry, my bad. We did capture this. Okay, so that means it's working correctly. Let's look at 18. 18 also ended early. 18 ended 392. Sorry, 392. Oh, so it's still active. And it's still active. Action, observation. Okay, this is the same term. This file is very hard to read. It's really hard to read. Okay, I can't even collapse this thing because it's too long. So this is the previous turn and this is the next turn, and the reward is give as done. but we didn't get the thing. We didn't get the thing. Let's see what went wrong in our logic. Status done, reward -8. 393. 392. It's already done. It's done on 392, not 393. That's a problem. That's a problem. That's why it's calculating wrong. Done. Okay, it's very hard to read this. Let me read this very carefully. So can I collapse this? I can't collapse this. Players, let's delete this as well. I don't really care about this. Okay, so this is 31391 and we're still active. Right, this is the critical one. We're still active actually in 392. Wait, 392. 392. Wait, is the first one step 0? Steps first one. Step is 0, right? So why did it end on 392? 393 is done, right? Okay, let's take a look at this. I equal to step -2. It's done. Okay, I think this is a problem. I think this is a problem. So the total steps here is total number of steps here is 3930 is 1. Yeah, so the total number of steps is 394, which means it's ended one step too early. What if we don't end one step too early? That's gonna cause us to have no. Actually, I think it's fine. Yeah, let's just remove this and see how it goes. I feel like that's okay. Should be okay. should be okay. Either I think it might cause the array out of bound problem. Might cause the array out of bound problem. Done. Entering is done. That's done. Let's just try to run it and see what happens. I think if it hits the array out of bound, we can just ignore the last round. It should be fine. Stopping at 350. Okay, it's definitely not stopping correctly, no. Episode 1, let's take a look at how this one looks like. I have to kind of understand how this file is structured, especially on the last few rounds. It's actually done, right? It's actually done. Oh, I see why. Because it. Okay. Okay. I think I shouldn't stop. I shouldn't stop here. Yeah, I think this is more correct. Yeah, this is more correct. I think the last turn we just ignore the next part because I think the formula is gonna handle it anyway. So we don't need to worry about the next part being not correct. Yeah. But there's a lot of edge cases to handle in this kind of problems. You need to know those edge problems. So now it's ending correctly, hopefully. It's still very biased towards the action 0. Should I even remove? Don't know. Oh wow, the loss is actually increasing. I mean, it's fine. I guess it's fine. It's fine that the loss is increasing. In the beginning, oh no, it just keeps on increasing. Oh no, that's not a very good sign. That is not a good sign. That is not a good sign. Maybe it's too noisy, that's why it keeps increasing. Our queue is not always increasing, which is also problematic. At least like the basic setup is there, right? There's like the basic things are working. We're getting the correct state. I'm not too sure if we're feeding the correct tensor. So that's something I'm gonna need to take a look at. I didn't expect the loss to be so huge actually. And now it's starting to lose, which should help it to reduce the loss. It's never taken action 1. Huh? That's interesting. It has never taken action 1. But what is action 1? Why is never taking action 1? Mine. It's not mining. Default move. Oh no, I know why. No why this C is included in the launch. Oh my god, that's such a stupid mistake. C is included in the launch. That's why it's. Oh my god. Okay. That's a super stupid mistake. That is a very stupid mistake to make. Not gonna lie. Okay. Spawn. We need to find some replay that give us a good outcome. Okay, actually we can just get those downloaded ones. Launch underscore something C, right? So I guess we're supposed to split between the launch and then check if the third one has C. Okay, I think that's a good strategy. Const action parts equals to action split underscore and then flat path. Let flight path equals to this if action parts 0 equal to launch, then flight path equals to action 2 and action parts dot plan equal to 2. Oh, sorry, it should be equal to 3. And flight path, then we can check action equals launch. Actually, we don't need action equals launch, but it's better. Okay, so now we fix this problem. And now we should see action 1 coming in. Hopefully we get a decent agent from this, and then we can beat the simple agent. Okay, it's taking action 1 already, so that's pretty good. Okay, mix of 2 and 1. The loss is much lower as well for this round. I mean, I'm not supposed to see good results from the first less than 1 million round, right? I think our replay memory, the epsilon decay thing is, let's see what we set it as. Epsilon decay frame is 1 million, yeah. So it takes at least 1 million to get good results. It's nice that our loss is actually reducing very fast. It's dropping very fast. And now it's increasing. I just jinxed it. Okay. So far I haven't lost, so need to make it lost somehow to get a better. Oh wait, why is there's no action 3 now? Maybe I screw something else up. If launch and flight paths. So 0, 1, 2, 3. This is 3. It's definitely something wrong here. Let's stop here. I think our this thing is not working correctly. Let's do a quick debug. Oh wait, it's actually doing the correct thing. Oh, I think I know why. Because the build shipyard doesn't actually execute it. Yeah, the build shipyard doesn't actually execute it. Okay, I see. Should I allow it to execute? Oh. Okay, I think we'll leave that to tomorrow because today is already quite long. I think I know how to fix this. I just need to let it execute it, no matter whether it's correct or wrong. I just let it execute. And it's gonna figure out eventually that when to execute it. Hopefully, I hope that's how it works. But yeah, anyway, I think we accomplished quite a lot. We managed to get this DQN set up correctly, and as you can see, it's somehow working. Not really super well, but it's something resembling a decent setup working. I think I'm pretty happy with the progress that we made today. Yeah. So okay, let's not add so many files. But I think yeah, that's all I want to do for today, and we'll continue this training maybe tomorrow, so that we can do some proper setup. I think a lot of things are not set up correctly still at this stage, so I want to set it up correctly maybe tomorrow. But we did manage to run some training. All right, I think that's all for today's stream. Thank you all for watching, and